Hi, welcome back for another 5 minutes in New Zealand with data mining with Weka. This is lesson 1.3 and we're going to look at exploring datasets in this lesson. So we looked at this data file in the last lesson. It's the weather data, a toy dataset of course. It has it's about 14 days or instances, and each day is described by 5 attributes. 4 to do with the weather, and the last attribute, which we call the class value, the thing that we're trying to predict whether or not to play this unspecified game. So this is called a classification problem. We're trying to predict the class value. Let's open up Weka. It's here on my desktop, and I'm going to go into the Explorer. We always use the Explorer. I'm going to open the file, and I put the data sets in my documents folder so I can see them here. I'll just open the Weka data sets and the nominal weather data. So there's the weather data in Weka, and as we saw last time, you can see the size of the data set, the number of instances, 14. You can see the attributes. You can click any of these attributes and get the values for those attributes up here in this panel. And you also get at the bottom a histogram of the attribute values with respect to the different class values. The different class values are blue for yes, play, and red for no, don't play. By default, the last attribute in Weka is always the class value. You can change this if you like. If you change it here, you can decide to predict a different one other than the last attribute. So that's the weather data set, and we've already explored that. As I said, it's a classification problem, sometimes called a supervised learning problem. Supervised because you get to know the class values of the training instances. So we take as input a data set of classified examples. These examples are independent examples with a class value attached, and the idea is to produce automatically a model, some kind of model that can classify new examples. That's the classification problem. And here's what the examples look like. This is an instance with the different attribute values, a fixed set of features, and then we add to that the class to get the classified example. That's what we have to have in our training data set. These attributes or features can be discrete or continuous. What we looked at in the weather data were discrete, or we call them nominal attribute values, where they belong to a certain fixed set, or they can be numeric or continuous values. And also the class can be discrete or continuous. We're looking at a discrete class, yes or no, in the case of the weather data. But another kind of machine learning problem would involve continuous classes where you're trying to predict a number. That's called a regression problem in the trade. So I'm going to have a look at a similar data set to the weather data set, the numeric weather data set. Let me just open that in Weka. Weather.numeric.arf, and here it is. It's very similar, almost identical in fact, for 14 instances, 5 attributes, the same attributes. But maybe I should just look at this data set in the edit panel. You can see here that 2 of the attributes, temperature and humidity, are numeric attributes, whereas previously they were nominal attributes. So here there are numbers. And what we see when we look at the attribute values for outlook, just as before, we have sunny, overcast and rainy. For temperature though, we can't enumerate the values. There's too many numbers to enumerate. We've got the minimum and maximum value and the mean and standard deviation. So that's what Weka gives you for the numeric values. Okay, I'm going to look at a different data set. I'm going to look at the glass data set, which is a rather more extensive data set. It's a real-world data set, not a terribly big one. But, let's open it. So here we've got 214 instances and 10 attributes. And here are the 10 attributes. It's not clear at the moment what they are. Let's look at the class by default, the last attribute shown. And there are 7 values for the class, and the labels on these values give you some indication of what this data set is about. We've got headlamps, tableware starting from the bottom, containers, and then we've got building windows and vehicle windows, float and non-float. You may not know this, but there are different ways of making glass, and the floating process is a way of making glass. So these are 7 different kinds of glass. And what are the attribute values? Well, I don't know what you remember about physics, but and I guess it doesn't matter if you don't remember, but Ri stands for the refractive index. And it's always a good idea to check for reasonableness when you're looking at data sets. It's really important to get down and dirty with your data. So here we're looking at the values of the refractive index, a minimum of 1.511, the maximum of 1.534. It's good to think about whether these are reasonable values for refractive index. If you go to the web and have a look around, you'll find that these are good values for the refractive index. Na, well, if you did chemistry, you'll recognize Na as sodium. Here it looks like these are percentages, the different percentages of sodium, magnesium, Mg, and so on. We would expect Si, silicon. Where's silicon? Yeah, that makes up the majority of glass. It varies between 69.8% and 75.4%. So these are percentages of different elements in the glass. We can confirm our guesses here by looking at the data file itself. Let me just find the glass data. It's in Weka datasets. I'm sorry, I didn't mean to open that. It's in Weka datasets, and it's glass.arf. This is the ARF file format. And it starts with a bunch of comments about the glass database. These lines beginning with percent are comments. And you can read about this. We don't have time to read it now. But you can see about the attributes, and it does say that the attributes are refractive index and sodium, magnesium, and so on. And the type of glass, just like I said, is about windows and containers and tableware and so on. We can get down to the end of the comments. And here we have stuff for Weka. This is the ARF format. The relation has a name. You'll see it printed in the interface when you look. And then the attributes are defined. They're real valued attributes, numeric attributes. The type attribute is nominal, and the different values of type are enumerated here in quotes. So that defines the relation and the attributes. And then we have an @data line, and following that in the ARF format are simply the instances one after the other with the attribute values all on one line, ending with a class by default. So this is the class value for the first instance. And I think there are 214 instances here. There's the last one. So that's the ARF format. It's a very simple textual file format. And now we've confirmed our guesses about these being percentages, these numbers being percentages of different elements. We just move that out of the way. We can think about this some more. So it's important then that these numbers are reasonable. If they went negative, for example, if there's a negative value in there, that would indicate some kind of corrupted value. You can't have a negative percentage. We're expecting silicon to be the majority component. We're expecting the refractive index to be in this kind of range. So it's always a good idea when you get a data set to just kind of click around in the Weka interface and make sure things look real, rather small amounts of aluminum in glass. I guess that's not surprising. I don't know very much about glass myself. So we're just kind of checking for reasonableness here. Very good thing to do. Okay. That's it then. We've looked in this lesson at the classification problem. We've looked at the nominal weather data and the numeric weather data. We've talked about nominal versus numeric attributes, and we've talked about the ARF file format. Looked at the glass.arf data set, and I've talked about sanity checking of attributes and the importance of getting down and dirty with your data. If you'd like some further background on this, you could go with section 11.1 of the text and read about preparing the data and loading the data into the Explorer. Whether or not you do that, please go and have a look at the activity associated with this lesson. We'll see you soon. Bye.